All right. So we're going to kind of cycle back. We've looked at questions like this before, and this is a really important question when we are in our function type questions on the regions. So straight from the regions, it says a map is shown below. See, we know our domain, our x values is January, February, March, April, and we know our range or y values is 28, 29, 30, 31. So another way of thinking about it is our domain is the months and our range are the days. The question is, this map is a function because February has two outputs, all right? A function because two inputs, January and March, result in the output of 31. 3, not a function because February has two outputs, 28 and 29. Or 4, not a function because two inputs, January and February, may result in an output of 31. Okay, we got to remember our rule. And our rule is very simple. The rule is this: one output, one input rather, for one input can only have one output. Now, this is a very simple but a very profound way of looking at functions. And what I really want you to take away from this is that um, it's totally cool for our our 31 to have two inputs. That's all right. January and March. That's not a problem. What's a problem is that February, which is an input, has 28 and 29, which is two outputs. So this is the problem. The problem is here with February, okay? And because February is the problem, this is the answer that we're looking for. Not a function because February has two outputs, 28 and 30. That is the answer that we're looking for, okay? All right, so I hope that helps. Let's go on to our next question. And our next question, um, what we're basically going to do is we're going to revisit this idea of equivalency based on our ability to know our graphing calculator in and out. So let's look at the next one here. Okay. So we're told the following. We're told that four expressions are below. All right. And the expressions look as follows. This is 1, this is 2, 3, and 4. And we're being asked to compare against this expression here, 4x squared minus 4x minus 120. Okay? And like in my previous video, step 1 and step 2 are the most important thing we do. And in step 1 and step 2, what we do is we store values into our calculator. And after we store values into our calculator, we look at what it produces. Okay, so 4x squared minus 4x minus 120 is going to produce a value of negative 118. So we're looking for the expression that doesn't give us back negative 118. And that's how we're going to base our decision making on. So let's kind of go through it. So let's get 3 here. 3, put that into our calculator. 3 corresponds with our first option. That's going to return negative 118. So we know that's equivalent. All right, methodically, we do the same thing with expression 4. expression 4 also returned negative 118. So this is right, and this is right. Okay. So good, good. Let's keep working down the line. Step 5. We're going to evaluate the third option. Oh, and here we are. That doesn't return negative 18. Okay. So this is something that we got to be mindful is not going to be in our solution set. Okay. All right. Okay, get out of here. I don't want to highlight it. What do I want? Yeah, just a regular pen. Okay. Get that out of there. And finally, we take a look at step 6. And you figured it. It returned negative 18. So we can now basically have a conversation on the options for the question. Yeah. So what were we asked to eliminate? We were asked, this is always fun, y'all. Okay. We were asked, is it 1 and 2? Is it 2 and 4? Well, we know it's 1, 2, and 4. So we can eliminate 1 and 2. So our best option here is number 3. Number 3 is the correct answer. Okay. All right. We're going to pause the video and get you guys ready for the final installment of Rule 3. If you were given an expression and asked to find an equivalent one, plug in values and compare.